Chapter 4.1, Additive, Multiplicative, and Ciphered Systems of Numeration. So in this chapter, we're really going to get into what is a number system. So first, we need to talk about what is a number. Now, of course, you generally have an idea what a number is, but let's give it a more rigorous definition. So a number is a quantity that answers the question, how many? Then a numeral is a symbol such as X or 10 for 10 that is used to represent a number. Thus, a system of numeration consists of a set of numerals and a scheme or rule for combining those numerals to represent numbers. We will look at 4 types of systems that are used by different cultures throughout history. An additive system, multiplicative system, ciphered system, and place value, which is the one that we use today. So before we get into exploring the number system that we're used to, we're going to look at some historical number systems to compare it to. So first we will start with the additive systems. An additive system is one in which the number represented by a particular set of numerals is simply the sum of the values of those numerals. It's one of the oldest and most primitive types of numeration systems. It also happens to be essentially the simplest to translate from, but it can become very cumbersome when we're working with higher numbers. For example, we will look at Egyptian hieroglyphics and Roman numerals to represent these systems. So on the left we can see the Egyptian hieroglyphic number system. Looking at Hindu-Arabic numerals, being the ones that we use in our number system today, you can say that 1 is represented by a hieroglyph of a staff. 10 is a hieroglyph of a heel bone, 100 a scroll, and so on. Notice that we only have representations of powers of 10. 10, 100, 1,000, 10,000, etc. It's because we can then use these representations and add up. If I wanted the number 30, I would just need 3 10s. If I wanted the number 700, I need 7 hundreds. So I can write 7 scrolls in a row. So if I want to write the following numeral in our Hindu-Arabic system, how would I do it? All I need to do is go through and count up the number of each type of symbol and see what that symbol represents. So this first symbol is the pointing finger, which represents 10,000 in our Hindu-Arabic numerals. There are 3 of them, so together that is 3 10,000s, or in other words, 30,000. Next we have the scrolls. The scrolls represent 100, and there are again 3 of them, so that is 300s. The heel bone represents 10, and there's only 1 of them, so we add in another 10. And the staves are just the number 1. There are 4 of them, so we add in 4 ones to get a total of 30,300. 10 plus 4 is 14. So 30,314. All we need to do then is just add up what each of these represents. There's nothing more to it. We don't have to understand anything further, and as long as we have the symbols in front of us, it's pretty easy to translate. We can also go in the opposite direction. If we wanted to write 1,203,462 as an Egyptian numeral, then we can break it down into smaller pieces. 1 million plus 200,000 plus 3,000 plus 400 plus 60 plus 2 breaks it down into each of its powers of 10. So we have 1 million, so that's 1 astonished person to write. We have 200,000, so that's 2 tadpoles. We have 3,000s, so that's 3 lotus flowers. We have 400s, so that's 4 scrolls. 6 10s, that's 6 heel bones. And 2 1s, that's 2 staves. Like so. So in total, all we have to then do is write them all out. We write them in numerical order from highest value to lowest value. This does matter, but we can translate even if it's not in the right order. And we're done. We have our number. But notice how many symbols I had to write to get this. It's a lot. Of course, in the Hindu-Arabic system, I had to write 1, 2, 3, 4, 5, 6, 7 symbols to get this number. But in the Egyptian system, I needed to write 3, 6, 9, 12, 15, 18 symbols. That's almost 3 times the number of symbols. And can you imagine if one of these numbers was, for example, a 9 instead of a 2? We'd need 9 of these staves, or 9 of the scrolls, or 9 of the lotus flowers. It can get very cumbersome when we have higher numerals because of how many symbols we have to write. So the Roman numeral system attempts to simplify this a little bit. But additive systems just tend to have that problem by default. So, Roman numerals have 2 advantages over the Egyptian system, however. First advantage is that it uses subtraction as well as addition. So, if we have, going by this chart, DC, thinking about it in the way that we think about the additive systems, the way we did the Egyptian, DC is 500 plus 100, so that's 600. However, if they are written out of numerical order, if I write CD, where 100 is before the 500, that tells me I need to subtract. So 500 minus 100 to get 400. Anytime they're out of numerical order like that, it means subtract. Then, it also uses multiplication to cut down on the number of symbols that are needed. So anything greater than 1,000, we can get by using a previously used symbol with a line over it. So 5,000 is the symbol for 5 with a line over it to mean 5,000. 10,000 would be X with a line over it. 100,000 would be C with a line over it, and so on. So we're going to start by writing the following CMLXIV into Hindu-Arabic. To do so, we start by translating each piece individually, but we are going to need to remember the order they're written in. So C is 100. M is 1,000, L is 50, X is 10, I is 1, and V is 5. So notice that these are not all in numerical order. So we're going to group together the ones that are not in order. So I have CM is not in order. Then L can go on its own, X can go on its own, but then IV is not in order. So this CM and IV, because they are not in order, means we're going to do subtraction. So CM is 100 and 1,000, so that means it is 1,000 minus 100. IV is 5 minus 1. So together, we can then just add everything else up. So 1,000 minus 100 is 900 plus 50 plus 10 plus 4 to get 964. So anytime they're not in that numerical order, and it'll always be just one, like 100 below or 1 below, something like that, that's when we use that. So if we want to represent the numbers 4 or 9, anytime we have numeral 4 or numeral 9, that's when you want to use the subtraction property when writing out Roman numerals. Any other numeral, we just write it up normally additively. But for the numbers 4 and 9, we need to use this subtraction. So, for a number 439, we're going to break this down into tens here. Tens, hundreds, and ones. So 400 plus 30 plus 9. So notice we've got a 4 and a 9 here. So 400 is going to be 100 away from 500. So we do 500 minus 100. And then 9 is 1 down from 10. So 10 minus 1. But 30 That's not a 4 or a 9. So we just figure it out from it's 10 plus 10 plus 10. We can then translate each of these. So 500 minus 100 means, just like over here, we've got that is CD. 10, 10, 10, that's 3 x's. 10 minus 1 is 1 less than an x, so it'll be ix. So in total, we get CD, xxx, ix. So again, the most confusing part of this system is remembering when to do that subtraction when you're translating. So just note, anytime you see a 4 or 9, think subtraction. Then just figure out how to get there. So it's 1 down from some numeral we already know. So 400 is 100 less than 500. And 9 is 1 less than 10. So that's where the 4 and 9 comes from. It's always going to be 1 less than a 5 or 1 less than a 10, essentially. So that's when we do subtraction. For anything else, it should always be additive. So 10 plus 10 plus 10 is 30. Yes, you could write that it is 20 less than 50. You could write XXL to say that it is 20 before 50, but that's not what we do. We only do this with one thing. We should only ever be writing one numeral that is on the wrong side, the subtractive side, the out of numerical order side. So, next we're going to move on to multiplicative systems. So, multiplicative systems are more similar to the Hindu-Arabic system which we use today. The one we're going to go over here is the Chinese numerals. So, these are written vertically. The top numeral from 1 through 9, the top numeral means 1 through 9, and then we multiply it by the power of 10 below it. Okay, so what does that mean? Essentially, here I have a 2 over a 10. So that means it's 2 times 10. Here I have a 4 over a 100. So it's 4 times 100. So if we want to write 538 as a Chinese numeral, we would break it down into, again, its powers of 10. So 530 and 8, each of its place values, which we will talk about a little bit later. 500 is 5 hundreds. So we're going to write that the way we wrote this, 2 over 10, 4 over 100. So this will be 5 over 100, 3 over 10, and then the ones place we just leave as 8. So 5 over 100, we just take the symbol for 5, the symbol for 100. 3 over 10, we write the symbol for 3, symbol for 10. And then 8, we just write the symbol for 8, and that is it. So we're not going to get too in-depth about this system. This is just one that I like to show as an example of another type of system that we can use that simplifies our the systems that we've looked at so far. It's getting a lot closer to what we're used to. Instead of saying the word 500, we write 5 and then 100, but it's still kind of doing what we're used to. It's even in powers of 10 like we're used to. Next, we have a ciphered system. So in a ciphered system, there are numerals for numbers up to and including the base, and for multiples of that base. The numbers represented by a particular set of numerals is the sum of the values of the numerals. Then ciphered numeration systems require the memorization of many different symbols, but have the advantage that numbers can be written in a compact form. So remember that when we talked about the Egyptian system, I said the reason the additive system has essentially been abandoned is because it is very cumbersome. It gets very long when we've written when we have many numbers to write, when we have large numerals. So our system simplifies that a lot. The ciphered system also simplifies it. However, the memorization of so many different symbols, instead of just, for example, in our system, our Hindu Arabic system, we only need 10 symbols. But for example, now ciphered systems are used all over the place, but we will look at the Ionic Greek system, which uses the Greek alphabet as its numbers. So in the Ionic Greek system, which was developed in about 3000 BC, it is a base 10 system just like ours is, and we'll get a little bit more into that later, where we have, notice, many different symbols are being used. We can also use an iota, which is a Greek letter, placed to the left and above a numeral to represent the numeral multiplied by 1,000. So once we get into larger numbers, we stop at 900, but if I wanted something like 900,000, then I would put a little iota up in the corner to represent that number. So we can get up to not quite a million in this way. So if I wanted to write the following, which is tau pi epsilon, in Hindu Arabic, I would look for each of these symbols and see what they represent. So tau is over here, 300. Next, pi is 80, and epsilon is 5. So I write out each of these, and then all I have to do is add them, 385. So once you have these in front of you, it's not too hard to translate. Now to write 1654 in Ionic Greek numerals, we're going to break it down into powers of 10 once again. It's place values, 1650 and 4. So we need 1 times 1,000 because remember we have multiplication by 1,000. So 1,000 is 1 times 1,000. So that tells me, because I do not have a number for 1,000, right? We stop at 900, that I'm just going to take the number 1 and put that little iota symbol. So I take alpha and put a little iota symbol next to it to represent 1 times 1,000. Next, we need chi for, oh, nope, no we do not, sorry. We need 600, not 60. So 600 is, there we go. And then 50, so we look for 50, it's new, and 4, we have delta. So we write each of these, there's not times 1,000 or anything like that, so we can just write them out simply from the chart. So notice the little iota symbol next to the alpha to represent that that is 1 times 1,000. And then we have the rest of our symbols directly. So you can see how, well, doing this system requires knowing a lot of symbols. There's a lot going on in this system, which is again why we've moved away from it for more systems that we use today, or at least the system that we personally use. We want to have it as simplified as possible. We don't want to have to know 20 different symbols in order to write out any given number. We want to have 10 symbols and repeat those 10 symbols over and over and over again. That's how our system works, and we're going to explore that a little bit further later.